Hey everybody, I thought I'd make a video for the guided notes today, just so you don't freak out, because they do kind of baby you through binomial and geometrics. They treat it, or the guided notes treat you like you've never seen them before, and we've seen them first semester. So I'm going to kind of simplify it a little bit and highlight the main points. So first off the bat, let's talk about the definition, or what it means to be binomial. So the key in binomial is that prefix bi. Bi means two. So we're looking for the key in these binomial situations to have two possible choices. So the guided notes give some examples: true, false, yes, no, defective, non-defective, male, female. You can make almost anything into two possibilities. Even cards, you could do red or black. You could do heart, not a heart. You could do a 6, not a 6. So you can make many things into these binomial situations. When you do have those two outcomes, we usually call them success and failure. All right, and specifically we use the letters P and Q, if you think back to first semester. So when this happens, when we have two outcomes, success and failure, the distribution of that variable is called binomial. Next thing, I found these notes on the internet. I don't really like this requirements. I like the requirements from first semester. Remember, we used bins first semester to be binomial, and then bits for geometric. Well, the bins, the B stood for binary, just like this one, meaning two outcomes, success, failure. The I stands for independent, meaning each trial must be independent. And the N stood for number, so that's different than this number 3. It's the same thing, they just use F instead of N, but a fixed number of trials for binomial. This ends up being the key difference between binomial and geometric. And then the S stood for success, meaning that probability was the success each trial. So I liked bins a little bit better. If you need to rewind the video to write it down, go for it. Or I'll go over it briefly on Monday or Wednesday whenever you're back in class. Last thing, extra rule it has here, the sample size must be less than 10% of the population size. That goes along with independent. Think about drawing cards. If you pick from a deck of cards, we always replace them. But there's many things in life and experiments in life and simulations and surveys in life where we can't technically replace when we sample. So as long as what we sample is less than 10% of the population, that independence condition will still hold without replacing. All right, let's go to an example, and I'm not going to show you all this hoopla at the bottom. So, or actually, let me skip ahead to the definition of a binomial. So first semester, we looked at a formula for binomial, and we saw this formula after we talked about combinations. Because what a binomial does, if I'm interested in, I want to say probability of X here is the probability of X successes in N trials. So I'll say that again. P of X for a binomial is the probability of getting X number of successes amongst N trials for some given probabilities here. So what the formula means, I like this one a little bit better down here. What this formula means is N choose K. That's the same thing as combinations of N things taking K at a time. Sorry, probability of X equals K. I want, out of this many trials, I want to choose how many ways can I succeed, times the probability of succeeding that many times, K times. If I succeed a certain amount of times, that means I fail the rest of the time. So we learned, I showed this formula briefly, but then we kind of stick to binomial PDF and CDF. So this formula, again, will say combinations, how many ways you can get K successes, times the probability that you succeed K times, times the probability you fail the rest, right? N minus K means you fail the rest. So let's look at this formula and this first example on the first page. So Tom is about to take a 5-question true or false test. So what that means for us is N is 5. There's 5 questions. And the probability of success, if it's true or false, that probability is 1/2 or 0.5, whatever you prefer. So and I got N and P already. He'll be guessing. That's why my probability is 1/2. He's guessing. He has no skill here. And he's going to guess on all 5 questions. What's the probability he guesses all of them? Meaning the probability x equals 5. So out of 5 questions, he gets all 5. If I use the formula, and I'll show you with Binomial PDF as well, but if I use the formula, I'm going to have n choose k, or 5 choose 5, right? How many ways can he answer 5 questions correctly? Times p, 1/2 to the 5th, because I want him to answer all the questions correctly, times q is also 1/2 to the 0, because he answered all 5 correctly. That means he answered none incorrectly. So formula-wise, it would look like this. 5c5 times 1/2 to the 5th times 1/2 to the 0. You could do this without binomial. Or what we did first semester, we saw equals. So in the calculator, we chose Binomial PDF. And in the calculator, I'll bring out my calculator in a second. I'm going to have to pause. But in the calculator, it's going to prompt us. It's going to prompt us for n, it's going to prompt us for p, and it's going to prompt us for x. And our x here is 5. So let's go to the calculator and let's compute this using a Binomial PDF. That formula is a lot of work. So I got a menu, probability, distributions, and if I scroll down, it might be a different letter in yours. There's Binomial PDF. I have 5 trials. My probability is 1/2. And I want all 5 successes. I click OK. I get 0.031. So what this looked like, it was 5, 1/2, 5. And I got 0.031. All right, let's look at another one. I'm going to skip number 2 for now, but you can try. It's going to end up being the same. This will be a 0, 5 choose 0, 1/2 to the 0. Oops, I should have had a 0 here. 1/2 to the 5th, meaning he was wrong. He was right, never, 0. He was right, 5 all the time. So you're going to get the same probability. I want to jump down to number 3, something a little bit different. He gets exactly 3. That's the probability x equals 3. So formula-wise, what this means, how the formula works, and we don't really ever have to use it. 5, I have 5 questions. I want to make combinations. How many ways can he answer 3 correct? That's really what this picture down here is showing. They give you all this extra stuff, but this picture is showing how many ways he can answer the questions. Like there's 5 correct. Here's 4 correct. All the ways he can get 4 correct. And then how many ways can he get 3 correct? Well, the combination in the formula does that for us. So this is 5 questions. How many ways can he answer 3 correctly? Times the probability he answers 3 correctly. That's 1/2 to the 3rd. And then if he answered 3 correctly, that means he had to answer 2 incorrectly. So this is 1/2 to the 3rd. Or sorry, to the 2nd. Because he has 5 questions. 3 were correct, 2 were incorrect. Or again, in the calculator, I can do Binomial PDF. Sorry, I'm writing with my finger at my desk. PDF. PDF stands for probability distribution function. So I'm going to do it again. So menu, distributions, or sorry, menu, probability, distributions. I want to go down to Binomial PDF. 5 trials, probability of success is 1/2. I want exactly 3. Oh, poop. Hold on. 5, PDF. Exactly 3. And I get 0.3125. So I think that'll be 313. And let me do one more here, and then I'll skip to just another example in this packet. He'll pass the quiz. So to pass here, he needs a 60 or better. So a 60% on a 5-question quiz is 3 or more. He needs to get 3 or more correct to pass. So now I want to know the probability x is greater than or equal to 3. And this is where we really appreciated the calculator first semester. Because if I wanted to find this without it, I'd have to do this formula for 3 for 4 and for 5 and add them up. Instead, in the calculator, we can pick binom CDF. The C, binom, the C stands for cumulative. So cumulative means it's going to add for us. Let me go to the calculator. Menu 5. Let's look for binomial CDF. It's going to be right below PDF. I have 5 trials, 5 questions. Probability of success is 1/2. I want 3 to 5. Greater than or equal to 3 means 3 questions right, all the way up to 5 questions right. I click OK, and I get 0.5. So that was 5. Probability is 1/2. 3 to 5. And we get 0.5. So all this stuff on this first page that might be a little bit confusing because it's a little extra. It's just this is the combinations. This is showing how many ways he can answer 1 question correctly, how many ways can he answer 2 questions correctly, so on. We don't have to do all that anymore because we have this binomial distribution in the calculator that can find those probabilities for us. Let me do one more here. I can let you read through the rest. Oh, formulas, all on the formula sheet. This is also on the formula sheet on the AP exam formula sheet. I mentioned in my B-Day class today that some multiple choice questions will use the formula. It'll have a binomial situation and the choices will be in the formula. I'll try to find some for you by next week, but that formula is on the exam sheet, so if you have to use it, it usually will be in a multiple choice format. These formulas are also on the AP exam sheet for mean and for standard deviation. Keep in mind this 1 minus P, I think we just called it Q first semester. So keep in mind, I think we did NP was the mean, and the square root of NPQ was the standard deviation. So I'll do this one last example, and I'll move on to geometric. Suppose Charlie manages to manipulate a coin in such a way it lands on heads with a 0.7 probability and tails with a 0.3 probability. Suppose John then flips the coin 20 times. What is the probability it will land on heads exactly 13 of the 20 flips? Let's answer that first. So here I'm given N was 20 flips. Should have wrote it down as I read. N was 20, P was 0.7 for heads. And they actually told us Q. They usually don't tell us Q, but Q is always the complement of P. And I'm asked to find the probability. It's exactly 13 heads. So the first thing you ask yourself, well, is this binomial? Yes, it is. I got 2 outcomes. I got a fixed number of trials. Second thing, is it PDF or CDF? So because this is only in equals, there's no inequality here, I'm going to do PDF. I'm going to do binom PDF. And my trials are 20. My probability is 0.7. And I want 13 successes. So if I go to the calculator, menu 552. Oh, sorry, that's normal. Menu 55. Scroll down to binom PDF. 20 trials, 0.7 success, and I want 13. I get 0.164. And then the question asked me something else. I got a minute left on my recording. On average is mean. How many flips will result in heads? So mu is N times P. So I'm just going to do 20 times 0.7. So that's going to be 14, I believe. And standard deviation, I'm going to do the square root of NPQ. So square root of 20 times 0.7 times 0.3. And you can go ahead and type that in the calculator, whatever you get when you type that in. My recording is out of time, so I hope that helps you a little bit with those guided notes.